Ding. And we're good. Right. Okay. So I'll just do my intro and then over to you. So welcome everyone to the 2020 APAC Groundbreakers virtual tour by APAC OUC. This year it's the biggest of these that we've ever done. We've got 174 sessions, including normal presentations, workshops, and hands-on labs from 123 different speakers over 11 days and in 4 different languages. So that's pretty impressive. So do remember to register to as many sessions as you can. And all sessions will be available to replay as often as you like for the next 2 weeks after the initial session date. So from today, essentially, for this session on the heysummit.com site on the page for the session. There's also a comments section on that page as well if you want to post any comments or questions there as well during that 2-week period. So I would just like to thank the Oracle user groups and Java user groups that made this event possible, and also the sponsors, Oracle Groundbreakers and CloudDB. So for today's session, or the current session, we have How to Secure .NET Applications with Oracle Database by Alex Key from Oracle. Please feel free to write any questions during the session into the Q&A tab of the Zoom webinar, and we'll answer those at the end of the session. If there are any issues during the session, please feel free to contact me in the chat tab of the Zoom webinar and I'll see what I can do. So without any further delay, I would like to leave you with this interesting session by Alex Key. So I will stop sharing my screen so that Alex can take over.
Okay, I will share my screen. So thank you, Nigel. So for the next 45 minutes, we'll talk about how to secure your .NET applications with Oracle Database. As Nigel introduced me, I am Alex Key. I'm a product manager here at Oracle. I work out of headquarters in the United States in Redwood Shores. And this session, we're going to focus on very specifically using Oracle Data Provider for .NET or ODP.NET and the security features it has, and to use that with the Oracle database. So we won't be talking about security in general or security in the database per se, but what you can do as an application developer to better secure your .NET application when you're using the Oracle database. What are the options available to you? What are the trade-offs, and what should you consider as you are considering what security features you want to enable that you can use from ODP.NET. So it's broad in the sense that it will cover different aspects of security as you develop your application, but narrow in the sense that it's for those of you who are application developers and not necessarily DBAs, but application developers working with the Oracle database. There we go. So we'll start from where most people start out, which is, they start out trying to authenticate with their database. So we'll start talking about authentication, and then from there we'll talk about different other security aspects like using wallets, and then how to use encryption for secure communications and checksumming for data integrity. And then we'll talk about, from an application developer standpoint, other things you can enable and some of the trade-offs you might make when you are securing your application, but also want to maintain the ability to determine, control the privileges that end users going in. Some of the challenges, such as when you're using connection pooling, is you don't necessarily know who the end user is, because in a connection pool, every user is logged in as the same end user in order to enable connection pooling. But there are ways you can do that with the Oracle database by using things like proxy authentication and application context. And then we'll finish up talking about tracing. And tracing has kind of a special security aspect to it, simply because it's one of the few times you are sharing the innermost details of your application with a third party like Oracle support or another party organization, and you also want to be careful about the data you share there. And we have ways to we're planning to make it more secure for you to do so. So let's begin with authentication. And the traditional way of logging into Oracle database, from a .NET application is just the username and password. And that was, great for a long, long time until hackers started to get pretty good at finding out how to get a hold of your password. Things like, okay, I know that sometimes, if passwords are stored in strings, they'll be in clear text in memory somewhere. And if I can find that place in memory with the password, well, now your password just got compromised. So one of the ways .NET has tried to prevent that method of attack is by creating a new data type. Well, not that new anymore, but it's a data type that exists called secure string. And this .NET data type is something you can use to store passwords in. And you use it with a credential class. In ODP.NET's case, it's the Oracle Credential class. And what this Oracle Credential class allows you to do is store your .NET secure strings store your password as a .NET secure string. And that way, if there's a dump of memory, it's extremely unlikely that the hacker or third party can get access to any clear text version of the password, because it encrypts it for the most part, other than when trying to do a username password. When you're trying to authenticate, other than when you're trying to authenticate, it should be encrypted. And when it's done using it, the data is thrown away, so you can't even get access to it anymore. So it's something that makes the password much more secure if you're using a username password to authenticate, and to prevent it from being exposed in clear text in any way. In most ways, I should say, not in any way, but in most ways. So it's pretty secure, and it's available with both pooled and non-pooled connections. And each Oracle Credential class object generates a new pool, even if credentials of both objects are the same. So that's something to keep in mind. So when if you use the same Oracle Credential object over and over again, then they will be the same pool. But if you have two Oracle Credential objects and they both have the same exact properties, even though they have the same properties, they will each both independently create a new pool, even though they may have the exact same quote unquote connection string. And that's because each Oracle Credential object is considered unique. So that's something to keep in mind. So this Oracle Credential object is available in ODP.NET 18C and higher with our core ODP.NET Core version, which works with .NET Core, managed ODP.NET, and unmanaged ODP.NET. So all the different versions of ODP.NET. So let's take a look at this in a demonstration. And I will go over to my Oracle Credential demo here. So I'm in Visual Studio right now. I'm going to be using .NET Framework and managed ODP.NET. So here we have, we're using Oracle Managed Data Access. And I'm just going to log in and show you how to use the Oracle Credential class and then the secure string as well. So we have a connection string. We're just providing it a data source. And now I want to provide it my username and password. So first thing I do is I'm going to use a secure string. So I create the secure string. We're going to call it SCCPWD. It's a new secure string. And then I start appending the password to it. So here I've appended H and R, and that's my password, HR, for my HR schema. And then I make it read-only. And by making it read-only, it becomes immutable, so no one can change it from there. It can't be changed from there. And you also need to make it immutable in order to pass it to the Oracle database as a credential. So that's important to do. So call the make read-only method. And then from there, let's create our Oracle Credential class. So I create an Oracle Credential class. We give it a username and then the password that we've assigned it, which will take a secure string as the second parameter. From there, I create a new Oracle connection, and you can see this particular constructor. If I hover over this tooltip, will show me that it's a connection. It's the first parameter is a connection string, and then the second parameter is an Oracle Credential class, and that's what stores my password. So that's one of the constructors we added to support this new way of using of creating connections and using the Oracle Credential class. And there I just open and show I can successfully connect to the database, and I'm done. So let's just run this. I'm going to hit F5. It's going to build and run, and we should just see a message that we're successfully connected. Of course, if we didn't successfully connect, we'd hit an error and we didn't see the text. So we see that it worked. So that's how you use the Oracle Credential class. It's pretty straightforward. So nothing special there, but it's something new that we've introduced recently in 18C. So one thing you may think about as you look at this Oracle Credential class is, well, it's a little bit, it requires a little bit of work from a developer standpoint. And what happens when the password changes? Do I, as a developer, have to then go change the code, how it's handled, and things like that? And just managing usernames, passwords in general, kind of gets to be a little bit painful in these days of more heightened awareness of making your application secure. So what many people do in that case is they turn to using wallets and client-side wallets. And what client-side wallets allow you to do is store your credentials in a file or even in a Microsoft certificate store or something like that, and then use that. And then it becomes much more easy to manage, because if you have, say, hundreds of web servers and you and you find out your credentials have been compromised, you don't want to have to, say, change the password in all of them, or it might be easier to say, let's just put in a new wallet, and then the credentials have been changed, and we just simply copy over a new file, and we're done, to all the machines, which we can set up as some kind of large-scale automated job. And that becomes easier than, say, touching the code and ensuring everything got built correctly and everything like that. So wallets is something that has made things a bit easier to use, and that's why a lot of people now prefer to use wallets. They want to get out of the business of usernames and passwords for your application. So common way to store the wallet is this secure external password store that Oracle has on the client side. And all this SEPS is, it's SEPS for short, is its ability to store, it's a client-side wallet for storing your password credentials. So no longer have to embed your username and password within your application. So your application can kind of stay evergreen and don't have to kind of worry about that anymore, and it reduces your security risk. It also makes it much easier to manage in many cases, especially for those large scale applications. And it's something that ODP.NET supports with ODP.NET Core managed and unmanaged on Windows only for now. We're working on adding support for Linux and Mac OS for ODP.NET Core. That will be in the future, but for right now, it should all work for you on Windows. And really, it's there because it simplifies that large-scale deployment that many people have, that they don't want to be managing passwords. So how do you set this up? So first thing you want to do is create this wallet file, and this wallet file is an auto login wallet, something like the cwallet.sso file. If you've ever used the Oracle Autonomous Database, you'll know what this SSO file is, because you'll get a cwallet SSO, which is essentially just this external wallet that you have. And then you create the wallet and put it in a directory. So to create the wallet, you use a utility like mkstore that's available with the Oracle client. And you'll find this in I believe the bin directory. You'll find this in your Oracle home. It's not in the Oracle Data Access Components release. We don't include that utility, but in your normal Oracle Database Server install or your Oracle Database Client, the full install, you'll find this utility there. And with mkstore, you enter in a password and you create the wallet. And next, you want to set the wallet directory to tell ODP.NET where to find its wallet. And you can do that programmatically, which is getting to be more common with Oracle Configuration class, which is something we introduced with ODP.NET Core, and also Manage ODP now supports it in 19C. This Oracle Configuration class has a property called wallet location. And this wallet location points to the directory where you plan to store your wallet file in. And of course, you can store this also if you're using unmanaged or managed ODP.NET in your .NET config file, as well as your SQLnet.aura if you'd like. And then you just turn on SEPs. So programmatically, you turn on SEPs with the SQLnet wallet override and set that to true in the Oracle configuration class. And again, this is available with your .NET config and your SQLnet.aura. So any number of ways you can enable it, SEPs. And once you've enabled SEPs, you're kind of done with handling these external wallets. And then we'll come back to also using wallets, because wallets become also important when you're using it with TLS and SSL, which I'll cover in just a second. But that's how you use your secure external password store if you choose to go that way. So let's talk about encryption and checksumming, otherwise known as secure communications and data integrity. So with encryption and data integrity, many people, many developers and IT deployments have chosen to use transport layer security, or TLS. TLS is more commonly known as SSL, secure sockets layer, created by Netscape long time ago, taken over by an industry independent industry organization to manage, which also changed the numbering too for TLS, who has a new numbering system starting back at 1.0. But it allows you, the important thing from a technology standpoint, it allows you to encrypt communications as well as to ensure your data integrity, so that you can make sure your data has not been tampered with. So that's very key as well. It's widely used, very popular. We use it also for our autonomous database, and many clouds also use it as well. And it's something we support in all of our ODP.NET versions, core, managed, unmanaged. And as well as ODP.NET Core works on all of the operating systems it supports. So you'll be able to use it on all three. So how do you set up TLS? Well, first thing you want to do is create your wallet with your certificate. And it's a bit involved. How do you kind of create this wallet? So I'm not going to cover it here. But for most developers, they should just be able to grab the wallet from their DBA or some administrator that is managing the security. But you can use a wallet like from the stored in the file system. So you can grab it as a wallet. You can put it in the file system, or off the network. Or you can get it from, say, the Microsoft Certificate Store. ODP.NET supports that as well. And to create the wallet, you use something like Oracle Wallet Manager. And with Microsoft Certificate Store, you would say use your Windows domain credentials for those client credentials. So once you have your wallet, then you enable it with TCPS for the transport. And you can also enable it for authentication as well. So I'll just go over that in a minute. But for transport, to do that, you just set the protocol equal to TCPS. And this is something you'll see in your tnsnames.aura setting, that you can enable this TCPS setting. Normally it's TCP, but you just add the S to it and you have TCP/IP with SSL support. For transport, that is, I should say. And then you set your wallet location directory. Where are you going to find the wallet? And it's that wallet location property again that you saw before when we were using SEPs. So it's the same property there. To continue your setup, you can also choose which version of TLS SSL you want to use. By default, if you don't set this, we allow any version to be used. So you can use 1.2, 1.1 TLS, or 3.0 SSL. But you can also say, I just want, in this example here, version 1.2 or 1.1 to be used only. Do not allow any other version to be used. And you might set that for security purposes. And you set this through the Oracle configuration SSL version property you see right here. And there's SSL again. SSL has been so pervasive, it still exists in a lot of some of our newer properties such as this. And that's because we a lot of the properties in Oracle configuration we copied over from what exists in, say, SQLnet.aura, or say in SQLnet.aura, to make it easier for those who've used Oracle who use these Oracle client configuration files to be able to then take what they know into the ODP.NET realm. And so it uses SSL versions. So we decided to use it SSL, even though these are two TLS versions. Just a side fact there. And then we enable TLS SSL for authentication. So before we were enabling it for transport, now we're enabling it for authentication, which you don't need to do if you're not using it for authentication, but you can. And to do that, you set your Oracle configuration SQLnet authentication services property to TCPS. So that's how you set it for authentication as well. And of course, you can set this in your SQLnet or your .NET config if you'd like. So once you've set that up, then comes the setup for what kind of encryption algorithms you want to use, and then we'll get to checksumming after that. But let's do encryption first. Algorithms you want to use, and then how you want to enable that algorithm. So the algorithms you can choose from encryption standpoint are 3 advanced encryption standard algorithms. One is the 128-bit. The second one is 192 and 256-bit. And then we also support the triple DES algorithms, so 112-bit there and 168-bit. So on the client side, you would set what which ones you would allow. And then on the server side, it also sets what it allows as well, and then negotiates which one to use based on that. So for example, if you both have AES 256-bit as available options, it will then go to AES 256-bit, as seeing that both are in common. If it doesn't find something in common, then it's not going to be able to encrypt. So that's what this property is used for. So the exact property name that's there is called the SQLnet encryption types client. So that's where you enable one or more of these encryption algorithms in this property to indicate this client can use any of these algorithms if it wants. And then when you want to set whether to turn on encryption or not, you use the SQLnet encryption client. And these are both Oracle configuration properties, just to keep that in mind. And it's not kind of a true false setting here. It's got 4 different values. You can have accepted, rejected, requested, or required. So it's probably easiest to explain rejected and required first. So let me do that. Required means that on the client side, you are requiring that for a connection to occur, it has to be encrypted. And if the server side is not letting you do an encrypted connection, it won't connect at all. So that's what required means. It's the client is enforcing a policy to say always encrypt. And if you can't encrypt, I'm not going to let you connect. So that's what required. Rejected means is kind of the opposite. So if it disables encryption, even if the database requests it. So it won't allow any connection that is encrypted to be encrypted. It will be a regular TCP connection, for example. And then accepted and requested are, accepted says, I will kind of accept anything the server wants. You know, if it wants to have, if the server has requested or required status for the encryption, I'll enable encryption and use the encryption. If it doesn't, that's okay. I'll accept it as well. I'm easy. I'm loose. I don't care what the server wants to set up. I'll do any type of connection you want. Whereas requested is I prefer to have a encryption, but if it's not available, I will still connect. So it's kind of like it's a preference that if on the other side there's a preference also to do encryption, or if it doesn't really care, then it will encrypt. So that's kind of the way to explain it. So that was encryption, and data integrity is very similar. We have 4 algorithms: SHA-1, SHA-256, SHA-384, and SHA-512, and they also have their similar properties there as well off the Oracle configuration class. This one is Oracle Crypto Checksum Types Client, and that allows you to choose which algorithms are available for the client to use against the server to negotiate which one to use. And then we have the SQLnet Crypto Checksum Client itself, and that one is also have the same 4 possible values for its properties: accepted, rejected, requested, required, with the same definitions there. So as a general recommendation, when you're using TLS SSL, we do recommend you use the latest versions of Oracle software, whether it's the tools, the client, and the database, simply because we're always, looking to fix bugs, making improvements. We'll support TLS 1.3 one day, and we'll keep upgrading the security features because in security it can be sometimes fast changing depending on what hackers end up doing. For example, the MD5 algorithm has been found to be flawed in the sense that now hackers can fairly easily break it, and it's not considered secure anymore. Windows now restricts anyone using the MD5 algorithm, and then even back with Oracle 12.1, we were still using MD5 for Oracle or a PKI EXE for default wallet generation, but that's no longer secure. So we don't support that anymore, even though 12.1 is only a few years old now. So it's something to keep in mind. More than a few years, well, 5, 6, something like that. But it's not that too far away, and we still have customers using, say, 12.1, 11.2 out there. But it's just something to keep in mind that with security, it's always best to try to keep upgrading, to use the latest patches, at least use the latest patches, even if you're on an older version, because we'll ensure that security stays up there by using the latest patch. So let's talk about proxy authentication. And actually, before I get into this slide, let me just talk a little bit about some of the challenges that maybe using security provides you, which is that adding all these layers of security can, in one way, make it good because make it good in the sense that, hey, you can now ensure you can identify the end user. You can make sure they have the right privileges and be able to audit them and be able to track them. But one of the challenges that you may have as you're developing is, how do I scale if I identify each user uniquely and I can't use, and connection pool kind of is the antithesis of that, where in a connection pool scenario, every user coming in is the same user because they all have the same credentials. But if I want to ensure that the person entering my application is a real user, is a real person who's allowed to use the application or has only certain privileges, how do I do that while maintaining the scalability and the performance that a connection pool provides me? Well, proxy authentication is one of those ways. So proxy authentication, what it does is allows a real user to log in as the middle tier user. So a real user will be able to identify themselves. There'll be an actual user in the Oracle database. So the Oracle database will recognize them as a user. But at the same time, they will be connection pooled. They will be connection pooled because the proxy user will be the one that's creating the connection. So the proxy user will be the one whose connections exist in the pool, whose connections will be dispensed, but the real user will have its own session to do whatever activities the real user is doing. So that gives you the ability to retain your pooling performance and your scalability with pooling, but at the same time, you can now know this is a separate database user, so you can have that user identity. That user can have certain privileges, so you can decide, oh, they can access these tables, or they can have read privileges but not write privileges, or they have update privileges, et cetera, et cetera. They can be audited, of course, and this is available with all 3 of our ODP.NET drivers. So to give a little more substance, to hit it home, because it is very conceptual the way I've explained it, let me give you kind of a more real life example. So let's pretend we have the real user. We'll call that person HR, because HR is the common Oracle schema. Well, that's the ODP.NET user. That's the real person. That person's name, the user ID is HR. And then we have the middle tier user, which we'll call app server, and that's the proxy user. The app server is the one whose connections are all pooled. So it's kind of just a connection that's created, a session that's created, so that when ODP.NET says I need a connection and grabs it, it grabs that user connection and session called app server. And then when it grabs that connection from the pool, it then creates another session called HR. And now you have one connection with two sessions, but there's one session per user, one session for HR, one session for app server. And what gets cached in the pool is, again, app server's connection and proxy session, because when it goes back in the pool, HR session is then destroyed. So you are creating a new session coming in and out of the pool and destroying the session, but you get to maintain that scalability of that connection already being created. So let's see a demonstration of this. So right here. Okay. So we've got, let's go to the top here. So we're using manageodp.net again. And I've, just to give you some background, I've created a user called app server. And then I've granted that app server user ability to connect and resource privileges or roles. And then we allow HR to connect through that app server user. So that establishes the proxy user capability. So now if I do from the sys schema, I can then perform a query and select star from proxy users. I can see that this has been set up just to verify. So here I'm just using Oracle Developer Tools. We do a select and we can see that we have a client HR that can use app server as a proxy. Okay, so we're all set up. Let's see what this application does. And if you want to use any of this code for my credential class app server and my subsequent demo, I'll show you right at the end of the session where to get the sample code from so that you can try it out yourselves if you want. Okay, so here, this is how we set up our proxy user. We have a user ID and password, just like a typical user ID and password. So that's great. And then we have this proxy user ID app server and its proxy password. So that's all you need to do. That's it. That's all you need to do to kind of set it up. After that, then it's a matter of creating some logic in the database for how you want to use these user IDs and what ways you want to set the privileges and things like that. But that's all you need to do from the application .NET side. And one thing that's optional is the password. So you don't need, I should say, the one thing for the real user ID is optional is the password. You don't need the user ID's password because presumably you've done the authentication with the proxy user's session and connection. It's optional, but a lot of people do it because it's more secure if you include the user ID's password. But just to let you know, that's option there. So after that, we just open the connection. We create a command. Not that important what the command does. We're just selecting a first name for employees where department ID equals some parameter. We give it the parameter value of 20 and add that to the command. We execute. We read the results and we output it to the screen. And before I end, I'm going to have a read line here. So it's going to stop right here. And before I start disposing objects and getting out, the connection pool is, the connection is still being used. So I haven't exited that connection, but I'm going to run this query for you guys. And I'll know that the queries that were done because the employees all print out. But by the time we hit this line of code here, sorry, this line of code here, I'll run this query. And what this query does is we're going to select basically the username, from the $V session table. And we're going to look for the usernames with the app server or HR. And we should be able to see that there are two sessions created, so two SIDs will have been created, one for app server, one for HR. So let's run this. We should see if we successfully connect, we should not see an error. We should see two employees first name get returned, they do. And let's go back to the application and we're going to run that query I showed you. And we see that, yes, we have two sessions, one session for HR and one for app server as we expected. So that is proxy users. So let's talk about application context. Now, one thing as you're going through the proxy, thinking about proxy users is that um, it's nice that the database, you have another database user and all the foundational aspects of being able to manage users from the database. On the other hand, you can think about the downsides, which is, well, every connection has 2 sessions created, not just one. So that's more overhead. Not only that, the session gets created and destroyed every time it gets sent back to the connection pool, gets destroyed, and then a new session gets created, defeating a little bit of the purposes of the connection pool. So there's a trade-off that you have. I mean, it's nice that you have all the aspects of this HR user out there that you can create some database logic around in terms of managing privileges and things like that. But if you want something more lightweight, application context might be a better solution for you. So I'm going to talk a little bit about that. And what application context is you can think of it as maybe like tagging of your user session, or of the application, or what the user is doing, things like that. So providing some kind of string, and the string can represent any value that you want for the tag, and you just have in your database logic, if you can have the tag as, hey, this, I'm logging in, I'm Alex, but you can tag me as Alex. You can tag me as, I'm a gold customer. And based on that, Alex, or the gold customer, has a certain privileges and whatnot based on that. And the benefit is that you can have any number of tags you want, any which way. It's lightweight because it's just just one user session, one connection. The downside is that you don't have all the foundations around around having an actual database user. So you might have to recreate some of that if that's important to you. So as I said, it's a name value pair, and you can use any type of arbitrary string you want. It's up to your database logic to determine what that string means. You can use it to identify the person's identity, the user's identity, what type of resource they have access to, be able to log and audit what they're doing, track their resource usage if you have chargebacks and things like that. It's something like client ID, which is one of the properties, could be used with virtual private database or label security for access control. That's a very common usage of this client identifier for application context. And the benefits of it is that you get to keep your connection pool. So your connection pool is there, and no second session is created and destroyed, and does much more than just track identity. But it does require you to manage the application logic much more than, say, proxy users. Especially if, as a developer, you'll need to set these and use them as you go along. So what are the app context properties available? So we've got 4. We've got client ID, client info, module name, and action name. Commonly, you can really use these, like I said, for any arbitrary string, but usually people use client ID for what it's named, which is a kind of user ID. You don't have to, but most people do. That's why they call it client ID. Client info usually refers to something on the user session, maybe their language that they're using, or something associated with their client session. And then module name, maybe identifying what functional block they're allowed to access, like this guy's from HR or from accounts payable, and they should be able to access the HR schema or the accounts payable schema, things like that. And then action name is things like what are the privileges that this user can do, read, insert, update, are common ones that are allowed. And so with this, the properties can be set after opening the connection. And the nice thing about this is that when you set the property, you actually set the property in ODP.NET code in C#. There's no round trip when the property is set. What happens is that you set the property value, and then upon the next round trip that happens to occur, we will piggyback on that and provide the value to the database for this application context. So it doesn't create its own round trip, it just piggybacks on existing round trip. And it's pretty small, so it's not like it's going to generate it's a humongous amount of data. Well, as long as you're tags are fairly small. It won't generate a humongous amount of data. So it's pretty robust from a performance level from that aspect. And then when the connection gets returned to the pool, the app context properties get reset to null. So they don't have any value anymore, so that when the next user gets it, they don't get someone else's app context. Which is nice because that's secure. Not so nice in the sense that you'll have to reset it every time, even if everyone has the same application context. This is available with ODP.NET Core managed and unmanaged, so you can use it for all. The other thing I want to note is that the app context is also not readable. So once you set it, you can't ask. I should say ODP.NET itself can't read it again. It's not readable. It's just writable. The entity that reads it is going to be the database and the database logic. So let's take a look at a demo of this app context here. And so here we're using manage ODP.NET, and we're just having regular username and password, so nothing special here. And after we open the connection, I am setting some app context. So off the Oracle connection object, I have a client ID. I set that to Alex because it's me that's logging in, not just regular old HR. Then I have some action names. I want to retrieve some employees' names. That's what I should be allowed to do. And then HR.NET app is this module name. And I just put in some version 1 of this. I'm now not actually going to do anything with these values, these tags, but this just shows you how to set them. Generally you would say write PL SQL to do something with this information, or to use some kind of application logic in the database to decide what you want to do with this information. But based on that, then then this becomes much more useful. And there I just do what I've been doing in my past demo, which is just selecting employees from department 20. And then I will stop on this line here. And when I stop on this line, I'm going to take a look at the values where I can find these values. So I can find these off the $V session where the username is HR. And I'm going to, since that's the only HR user to log in, I will find out what value it has for action, client identifier, client info, and module. And the username, of course, which should be HR. And it should match everything up here. So let's run this. And we should see the values get returned. And now let's run this. And we see that our action is retrieve employee names. The client ID is Alex, version info is 1, and the module is HR.NET app. And this is for the HR username. So what we expected to be returned has been returned. And this is kind of how you use the app context feature. So that's it. Let's see. Okay, so let's end up with tracing. So that is kind of a global view of all the things you can think about and possibly use for securing your .NET applications. I just have one bit I wanted to finish up with about tracing, is that traces, as security becomes more important, one thing that developers want to do is if they're trying to debug their application, say with Oracle support or with other members of their team, they may not want, and they happen to do it, say in production, where maybe the problem only occurs, they may not want to share everything in the trace, because things in the trace may reveal some confidential information, some customer information. So what ODP.NET will have in 21C is a new tracing level to allow you to redact SQL statements and network packet contents, so that those won't be traced. Nowadays, what a lot of customers do is do that manually, which is a bit painful, but this will make it much easier to then share these traces outside your team, or if you're not supposed to see yourself what it is, to be able to get a trace without the information. So it makes it easier. This will be a trace level 8 if you're using managed ODP.NET or ODP.NET Core, or unmanaged trace level of 128. So that's there. One other thing I wanted to mention about tracing is that in 19C, we also introduced the ability to have a trace file limit and use dynamic tracing, which also should help in the security aspect, even though it was made more for the ease of use, in the sense that, by having this trace file size limit, you could then say, I only want trace file sizes to be 100 megabytes. Because sometimes when you get production issues and the problem only occurs after hours and hours of running the application, you end up with, gigabytes upon gigabytes of trace. And if you only want to see the last part of the trace and you want to share the trace file, you don't want, to have to upload gigabytes of trace anywhere. So the trace file limit lets you set, after it hits the limit, it'll create a new trace file and start writing there. Hits the limit again, create a new trace file. So the benefit from that, from a security aspect, is that, hey, you only have to share the last trace file you got, so it doesn't have to be the entire thing, which limits some of the service area for, the what's in the trace. And the dynamic tracing is also important because you can enable trace at will with ODP.NET, so that if a problem only occurs after 5 hours of running in production, you can turn the trace on at 4 hours and 59 minutes, and then you only have 1 minute of trace before the problem occurs. And the benefit of that is that it's much smaller trace, easier to find the problem, easier for Oracle too, because now we have a much smaller file to look through for problems than one that's very, very large. So that's something to keep in mind. So if you want to learn more, we have our Twitter site. You can sign up to get alerts from Twitter. We'll announce different things, new releases and new features, new blog posts and whatnot on Twitter. GitHub is where we find a sample code, and in a minute I'll show you exactly where to find this sample code I've done in this presentation. I'm sorry. First one is our OTN site. What am I thinking? OTN site is where you'll find a lot of information for about our product, our documentation, releases to download, things like that. Second link is our GitHub site. You can file issues there, as well as on our oracle.com site. You can file a GitHub issue on our GitHub site, and I'll usually answer questions there. Twitter is where you can get alerts about different new things happening in our product. YouTube, watch a video, or you can always email me. So the place to find these presentation samples is here. And why don't I copy and paste this to the chat so everyone will have a copy. And I guess I'll do it to the Q&A. I can't post to the Q&A, so let me see if there's some other place I can. Oh, here, chat. There it is. I found it. So I will send it to all panelists and attendees. So this is where you can find the sample code, and I also have it up here. And it's under this folder, and you'll find Proxy Authentication, Oracle Credential, and Application Context. So the code's right there for you to try out yourself. You saw in the comments, the setup for the code, so that it's easy for you to set up if you like. And with that, let me turn it over to questions, Nigel.
Okay, excuse me. Thanks, Alex. That was really interesting. I was impressed. I kept thinking of questions, and then you kept answering them.
Oh, that's good.
That was well done. So wait, I've not seen any questions in the Q&A, but we'll give it a moment just to see if anyone wants to ask anything. So I'm also going to present again later on in, I think, 3 hours. What time is it now? Let's see. Yeah, about 3 hours. I will be presenting also, if you guys want to catch my session on using Oracle Cloud with Microsoft technologies and integrating with Azure and the multi-cloud. So if that's of interest to anyone attending now, feel free to come to that session in about 3 hours. Okay. I don't see any questions, so no. Oh, I guess we can probably call it quits at that point then. So Thank you, everyone, for joining in the session today. Please remember to register to other sessions in the conference, and also remember that you can go to the heysummit.com page for the session, and the recording will appear within the next day or so. And that will be available for a couple of weeks. And again, you can post comments on that page as well. Other than that, thank you, Alex. Very interesting. And please enjoy the rest of the conference.
Thank you. Thank you, Nigel. And thanks to Francisco and his team for putting on the APAC Groundbreakers conference here.
Excellent. Well, thank you.